بسم الله الرحمن الرحيم. أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضة لغات، أهلا بكم. اليوم سنتطرق درس جديد في مادة الاستاتيكا بعنوان محصلة القوى المتوازية. Resultant of collinear forces. My dear student, welcome my dear student in our math program for second 3. Today we are taking new lesson. Its title, Resultant of parallel collinear forces. My dear student, look at example about resultant of parallel collinear forces. My dear student, if we have F1 act at A, F2 act at B, and direction of the resultant, its unit vector direction C. Look at, my dear student, resultant of two like forces, parallel forces, have the same direction. It's a force in the same direction as two forces. Its magnitude is equal to sum of magnitudes of two forces. What you mean? R equals F1 plus F2. And the line action divided the distance between the line of the action of the two forces and in the inverse ratio to their magnitude. What you mean? F1 times AC equals F2 times BC. Look at first example. Two like forces, magnitude 5 and 7 newtons, act at the 2 points A and B, where AB 36 centimeter. Find the resultant of two forces. Look at the solution. My dear student, we have two forces, 5 and 7. The two forces are like, parallel, and the same direction. What is R? Look at C is direction of two forces and direction of the resultant with the direction of the two forces. Why? Because in the same direction. The two forces 5 and 7 in the same direction. AB, its length 36 centimeter. Let's see B unit vector and direction of the two forces. F1 equal 5, C direction, F2 equal 7. Therefore, what is R? F1 plus F2 equals 12, 5C plus 7C equals 12C, or magnitude of R equals 12 Newton. Remember, my dear student, if we have two forces in same direction are parallel or like forces in the same direction, the resultant of the two forces equals sum of the two forces. If we find direction of R, or what is the point belongs to AB, is C far from A or B as a distant x centimeter. Look at, my dear student, identifying the point of action of resultant. Let's see belongs to AB line segment. AC over CB equals 7 over 5. Why? Because in inverse ratio, AC over CB equals 7 over 5. Therefore, we put AC over 36 minus AC equals what? 7 over 5. My dear student, AC over 36 minus AC. Why? Because BC equals 36 minus AC. Or we can put AC equal X. What is the BC? 36 minus X. This method, we write AC over 36 minus AC equals 7 over 5. By using cross multiplication, 5ac equals 252 minus 7c. Therefore, 5ac plus 7ac equals 21. 12ac equals 252. Remember, 5ac equals 252 minus 7ac. Therefore, we subtract, or we put left hand side 5ac plus 7ac equal 12ac equal 252, then divided by 12, therefore ac equals 21 centimeter. Therefore, AC 21. Therefore, what reduce BC? 36 minus 21 equals 15 centimeter. Then R equals 12 and act a point. This point is a distance 21 from A or 15 from B. The magnitude of resultant is equal to 12 newtons. It acts in the same direction of the two forces, and its act at a point is 21 centimeter distant from the point A. Resultant of two unlike forces in opposite direction. Look at, my dear student. In the opposite figure, we have two forces, its direction, opposite direction, F1 and F2 opposite direction. What is R? In this case, R equals F1 minus F2, and direction of R with the biggest direction, F1. C is the point which R acts on it. C is the point belongs to BA array, doesn't belong to BA line segment. In this case, F1 times AC equals what? Excellent student, F2 times BC. Remember, my dear student, AB equals BC minus AC. F1 and F2, two parallel unequal forces in the opposite direction, act at 2 points A and B, enlarge the body, and the resulted is R. Then R equals F1 minus F2. F1 minus F2. My dear student, act at a C. What is act at C? R, which divided AB externally. And F1 more than F2. Why? Because R with its direction with direction of the biggest force F1. We deduce that AC over BC equal F2 over F1, or F1 times AC equal F2 times BC. My dear student, look at the note that. It's important notes. Remember, my dear student, the resultant of two unequal and unlike forces is a force is in direction of the force of the greater magnitude. Its magnitude and its line of divided the distance between the line of action of the two forces externally, not internally, from the side of the force of the greater magnitude in as inverse ratio to their magnitude. My dear student, Look at important example. Two unlike forces of magnitude 40 and 100 Newton. The distance between their two lines of action is 240 centimeters. What is required? Find their resultant. Look at the solution. My dear student, look at, we have 100 force act at A, second force 40 at B. AB equals 240 centimeter. R is the resultant of two force act at point C, doesn't belong to BA line segment, belongs to BA array. What is the R? X and student. C is the unit vector in direction of the arc with the biggest force. Therefore, magnitude of R, when calculate magnitude and direction of R, let C be unit vector in the direction of the greater force. F1 equals 100. F2 equals negative 40. Why? Negative direction in the opposite direction. Therefore, R F1 plus F2 or 100 minus 40. In this case, F2 equal negative 40. We can say R F1 minus F2, 100 minus 40 equal 60 C direction. Magnitude of R equal 60 Newton. And CA over CB equals what? 40 over 100. CA over CB equals inverse ratio 40 over 100. Look at CA over 240 plus CA equals what? 2 over 5 divided by 20 in two terms. 40 over 100 equal 2 over 5, and use cross multiplication. My dear student, AC equals 160 centimeter. Magnitude of resultant equals 60 Newton at the direction in the same direction of the two force 100 Newton. It acts at point belongs to BA and doesn't belong to AB line segment. It's 160 centimeter apart from E. My dear student, look at this here. Sum of moment of a finite number of parallel coupler forces about any point in its plane is equals to moment of resultant of these forces about the same point. My dear student, this theorem is very important. We say again, the sum of moment of a finite number or a finite number of parallel coupler forces about any point in its plane, it's equal to moment of the resultant of these forces about the same point. Look at important example. Two parallel forces, magnitude 20 and F Newton, act at 2 points A and B. The magnitude of the resultant is 35 Newton. And the distance between the line of action of unknown force and the resultant is equal 15 centimeter. Remember, my dear student, the distance between the line of action of the unknown force F and resultant is equal to 15 centimeter. What is the required? Find F in each of the following two cases. The first case, the known force and the resultant are in the same direction. Find the F if known force and the resultant in the opposite direction. Look at the solution. My dear student, look at the opposite figure. We have F1 and F2 in the same direction. C unit vector of direction of resultant of the two forces, and unit vector direction with two forces. Why? Because in the same direction. F1 and F2 also are in the same direction. AC 15 centimeter. Let's see unit vector in direction of the resultant R equals 35, F1 equals 20, then F2, in this case we find F2 equals what? By subtract 15 C vector. The sum of moment about C is equal to moment of the resultant about the same point C equals 0. Therefore, 20 times 15 minus 15 times BC equals 0. To find the value of BC, 200 times 15, or we bought 20 times 15, 20 times 15 equals 15 times BC. We deduce that BC equals 20. Therefore, BC equals 20 centimeter. The force F2 acts at point at a distance 35 from A. Why? Because BC equals 20 and AB equals 15. We add 20 plus 15, then the force F2 acts at point at a distance 35 centimeter from the point A. My dear student, second case, look at in the opposite direction, the two forces, unlike parallel but opposite direction, are direction of F2, the biggest force. Let's see is the unit vector of the direction of resultant and F2. We know that AB 15 centimeter. C unit vector and direction of the resultant R. Therefore, R equals 35 from given F1 negative 20 C direction. Therefore, F2 by using substitution, F2 plus negative 20C equal 35C direction. Therefore, F2 equals 55 in C direction. This is the value of F2. After that, we know that 20 times 15 F1 times A BC equals F2 times AC. Value of F1 equals 20 times 15 equals what? Or minus 52 times BC equals 0. Moment about C. Therefore, BC in this case 60 over 11 centimeter. Force F2 act at point B as a distance 105 over 11 centimeter from A. My dear student, Now we are translate to another example. F1 and F2 are two parallel forces act at point A and B. F1 equal 40 Newton, F2 70 Newton. AB equal 50 centimeter. What is required? Find the resultant F1 and F2 if they have the same direction, number one. Number two, they have two opposite direction. Look at the solution. My dear student, look at in the opposite figure. F1 act at point A, its magnitude 40. F2 magnitude 70 acts at point B in the same direction. What is the magnitude of the resultant? Excellent student. In this case, R equals sum. Let my dear student AB equal 50 centimeter. Suppose AC length equal x. Therefore, we deduce that BC equal 50 minus x. My dear student, F1 and F2 in the same direction. Therefore, R equals 70 plus 40 equals 100 Newton. It's a magnitude. And we multiply F1 times AC equals 70 or F2 times BC. F1 40 times x equals 70 times 50 minus x divided by 10. Left hand side and right hand side, 4x equals 7 times bracket contains 50 minus x. Therefore, 4x equals 350 minus 7x. By using like terms, therefore, divided by 10, therefore 11x equals 350. What is the value of x divided by 11? 350 over 11. Then the resultant act at C from end A. C belongs to AB line segment. AC equals 350 over 11 centimeter. We deduce that, my dear student, R equals 110 and act at point C from end A 350 over 11 centimeter, or from B 50 minus 350 over 11 from B. Look at in the second case, my dear student. Look at AB equal 50 centimeter. BC, suppose at length is x. We have two forces, 70 and 40. We know that R magnitude of resultant with the biggest or the bigger force, 70. Therefore, R 70 minus 40 equal 30 Newton. In this case, R equal F2 minus F1, F2 more than F1. Therefore, R equals 30 Newton. What is the value of x? Or R acted at point C as the distance from B and from A. What is the value of x? By using the rule. 40 times AC. What is the AC? 50 plus x. Side bracket equals 70 times x. Divided by 10, left hand side, right hand side. Therefore, 4 times bracket contains 50 plus x equals 7x. divided by 10. And we use distribution method, 3x equal 200 or 200 equal 3x. X equal 200 over 3. The value of x, 200 over 3 centimeter. What you deduce, my dear student, are its magnitude 30 Newton and act at point C, from B with 200 over 3 centimeter, or from A 50 plus 200 over 3 centimeter. This magnitude of R and its direction. My dear student, by the end of the lesson, we know that the resultant of two forces is very important lesson. We have two cases. The first case, if the two forces are parallel and the opposite direction. The second case, two parallel forces in same direction. My dear student, I am very happy to spend such time with you. Thank you. Goodbye.